Okay, so if we start with this one, I have water, I have H2O, and this water exists at 1 atmosphere and 20 degrees Celsius. Okay, so what will be the phase we have? At this condition, 1 atmosphere, 20 degrees Celsius, do you think water will exist as solid or liquid or vapor? Liquid, okay? So water is existing as liquid. So if I have certain amount of water, this water, again, at 1 atmosphere, 20 degrees Celsius, I keep it at a piston, and then I start adding heat. So what do you think will happen? The temperature will increase, right? So the temperature will increase from 20 to 30. Temperature will increase from 30 to 50, but the phase will be the same, right? We still have liquid. And this will continue until we reach 100 degrees Celsius. At 100 degrees Celsius, we still have liquid. So we still have liquid at 1 atmosphere and 100 degrees Celsius. So if you keep adding heat for this water at this condition, so do you think the temperature will increase? So do you think you can have liquid water at 1 atmosphere at any temperature above 100 degrees Celsius? What do you say? No, this is not possible, okay? 100 degrees Celsius, this is the maximum temperature at which you can have liquid as water if the pressure is 1 atmosphere. So this is why it's called, we have something called saturation temperature and saturation pressure. This saturation pressure, saturation temperature are related to each other, okay? So if you have this limit, this saturation temperature, this saturation pressure, so this is the conditions after which this phase will not exist. So if you keep adding heat to this liquid water at 100 degrees Celsius, what will happen? Phase change will start to occur. So what we'll have here, you will start to have vapor, and also you have some liquid. Both of them, two phases exist. And both of these two phases at the same temperature, 100 degrees Celsius. You still at this temperature, 100 degrees Celsius. Okay. If you continue adding heat at this condition, so what will happen? More vaporization will occur. So what will happen? You can have 100% vapor at 100 degrees Celsius. So 100 degrees Celsius, 1 atmosphere, this is the saturation temperature and saturation pressure for water. So this means at this condition, phase change will occur completely. You have 100% liquid at this condition, and by adding heat, you have 100% vapor at the same condition. Okay? So the amount of heat you added to the system here and here, all of this heat is used to change the phase, not to increase the temperature. But if you reach this level, like 100% vapor at 100 degrees Celsius, and you continue adding heat, so what will happen? Temperature will start to increase again. So then we will have like 1 atmosphere, 300 degrees Celsius, and you still have 100% vapor. So this is how it started. You have 100% liquid at temperatures below the saturation temperature. You add heat, so the temperature will change. And then you can have 100% liquid at the saturation temperature. After this saturation temperature, phase change will occur. So here we have like, let's say 50% liquid, 50% vapor. So we don't have one phase. We have two phases exist at the same time at this saturation conditions. And once you have 100% vapor at this saturation temperature, any amount of heat added, it will cause increasing the temperature again. So if you need to like classify what we are doing here, so this is what we are doing. Here we are adding heat, and this amount of heat is causing increasing temperature. Here we are adding heat, and this amount of heat also increasing temperature. And here in this gray area, we are adding heat, but this heat is changing the phase. Not affecting temperature. Clear? So this is why we have two types of energy added to the system. We have something called sensible heat and something called latent heat. Did you hear these terms before? Okay. So we have sensible heat, it comes from sense. You are adding heat to the system and you can feel the temperature change. So this is why this amount of heat, any amount of heat you are adding, and the result of this heat addition is increasing temperature, this is called sensible heat. So you can sense this one. If you put like your arm, for example, you can feel the temperature is increasing. It's something that it can be sensed. Here also for this one, we have, this is called sensible heat. But here we are adding heat. We're still adding heat, we're still adding heat, but this heat is not changing the temperature. You cannot feel the temperature change. So this is called latent heat. Okay. So when you hear this word sensible heat, so this means we are adding heat to the system. This heat will not change the phase. This heat will change the temperature. We are adding latent heat to the system, so we are adding energy to the system. This energy will change the phase, not the temperature. So one of them change the temperature, not the phase. One of them change the phase, not the temperature. Clear? Okay. So this is what we have in this process. So for this process here, as we said, we have again, if you consider this one, so here we have 100% liquid at 100 degrees Celsius, mixture of liquid and vapor at 100 degrees Celsius, 100% vapor at 100 degrees Celsius. So for pure substances, the phase change occurs at a fixed temperature. At 100 degrees Celsius, you have 100% liquid and you have 100% vapor. This is not happening with mixtures. If you have mixture, and again, this is something you will study in thermodynamics too, phase change starts at one temperature and phase change completes at another one. So if you have mixture, for example, so you can have 100% liquid at 90 degrees Celsius. And then at 90 degrees Celsius, as with 100% liquid. 95, you can have mixture of liquid and vapor. 100, you still have mixture of liquid and vapor. 110, you can have 100% vapor. So you are moving from 100% liquid to 100% vapor through a range of temperature. But pure substances, and this is something only happening for pure substances, if you have pure substance, phase change occurs at fixed temperature. At this specific temperature, complete phase change will happen. Okay? 99.9, this is 100% liquid. 100.01, this is 100% vapor. So only at this temperature, 100 degrees Celsius and 1 atmosphere, we have phase change happening for water. Okay? If you have like different pressure, like 2 atmosphere, for example, so do you think water or phase change will occur at 2 atmosphere, 1 degree Celsius, or the saturation temperature will change? Again, remember, the properties are related, right? Temperature and pressure, these are properties. So if you change one of them, the other one will also change. So if you have water, 1 atmosphere, so the phase change will occur at 100 degrees Celsius. If you have water at 2 atmosphere, phase change will occur at different temperature. It can be 120 degrees Celsius, for example. If you have water at 0.9 atmosphere, so phase change can occur completely at 85 degrees Celsius. So these are related to each other. If you change saturation temperature will change. Okay? So this saturation pressure and temperature are related, but at any one of them, complete phase change occurs. Make sense? Any questions? Okay. If we need to plot what is happening here and we select to plot it on a TV diagram, it's called TV diagram because temperature, this is what we have on the y-axis. The volume, this is what we are using on the x-axis. And let's put numbers. So this is considered case number 1 or state 1. State 2, state 3, and this is a state 4, and this is a state 5. If you put state number 1 at 20 degrees Celsius, so this is case number 1. Case number 5, 300 degrees Celsius, so this is case number 5, 100 degrees Celsius. And if you see case number 2, 3, and 4, all of them at the same temperature. So all of them represented on this horizontal line. So here we can understand one thing from this TV diagram. So TV diagram, you can see many lines. But if you have line that like from 1 to 2, for example, or 4 to 5, this line representing temperature change, no phase change, only temperature change. So 1, we have liquid. 2, at this point, we have liquid. So 1 to 2, this represents the temperature change in the liquid phase. 4, at this point, we have vapor. 5, at this point, we have vapor. So this path, 4 to 5, represent temperature change in the vapor phase. So 1 to 2, this line, and this line representing sensible or latent heat. What do you think? 1 to 2, 4 to 5. Do we have temperature change or phase change? It will be sensible heat because we have temperature change, okay? But 2 to 3 to 4, so 2, this is 100% liquid. 3, this is liquid plus vapor. 4, this is vapor, and all of them at the same temperature. So this line, this horizontal line is called isothermal. Isothermal means we have constant temperature, and this represents latent heat. But the other paths from 1 to 2 to 4 to 5, this represents sensible heat. Is it clear? And again, this is the definition between them. So sensible heat, this amount of heat that causes temperature change without phase change. Latent heat, heat absorbed during a phase change with no temperature change.